Good news, nerds. This stuff is Super Algebra 1 that we're going to be talking about today. Super Algebra 1. Yeah, I'm sure it sounds good to a lot of people because we need those test scores to go up. So hoping that this next test is going to be very easy for everyone so we can get some A's in. Linear functions is what we're going to start talking about, and at the very end I'll introduce the concept of arithmetic sequences, but we won't do any work on them yet. We'll save that for tomorrow. Hey, they're going to be able to hear you talking back there while I'm trying to record. Equations of linear functions. There are 3 equations for linear functions that you need to know about. And yes, you need to know the forms. You need to know the rules. You're not going to get a reference sheet for this stuff. The very first one that we'll talk about is standard form of a linear equation. This is its setup, ax plus by equals c. Some very specific rules about standard form. A, the number in front of x must be positive. You can't have any fractions. And lastly, A, B, C as a triplet can't have any common denominators other than 1. So that's how we set up standard form. Oh, you can't have both A and B equal to 0, but whatever. What's it good for? It's really good for word problems, to be honest with you. Standard form is very good for word problems. A lot of things in the real world will work this way, and it would be because we could say that, let's just say burgers and fries. I could say, I'm buying a certain number of burgers at this price, a certain number of orders of fries at that price. This is my total cost. Where the price would have been your rate of your X and your rate of your Y, your A and your B. Whereas the numbers X and Y would have been the numbers of burgers, numbers of fries. So it's very useful in real world modeling style word questions. Word problems, I should say. Boom. Slope-intercept form. Everybody's good old pal, y equals mx plus b, called slope-intercept form because it gives you the slope and the intercept, the y-intercept specifically. Really good for graphing. It's also good for talking about real-world things when you want to talk about things that have fixed prices and rates as well. For example, let's just say I call a plumber, and he's got to do some work on the sink, and he's going to charge me $50 in parts. And then he's going to charge me $100 per hour. So when you get to say something like per, like that, it's a slope. So if dude works for 3 hours, we've got 3 times my 100 plus the 50 that doesn't change, $350. So it's easy to graph with, and a lot of things in the real world can be modeled with a linear equation, specifically things that only have one rate and then some fixed costs that don't change over time. The last one, point slope form, is called point slope form because it shows us a single point and the slope of our equation. The point that it goes through is x1, y1, which you see there and there. M is still the slope. This is very useful for upper level mathematics like calculus and things like that. You could graph with it though too. If you look at it, you see it gives you a coordinate and you see it gives you your slope. So you could plot the coordinate it gives you and then do your up or down, left or right slope stuff to graph. So good for word problems, good for graphing and word problems, good for graphing, not so much word problems down here. Good for calculus. We'll start with a couple layups here where we're just trying to write these things into standard form. No, you're not going to have test questions like this. That's way too easy. I'm not going to put that on a test. That doesn't test skill. But it doesn't mean that you don't need the knowledge. It just means I can't waste test time on a question like this. Getting this thing in standard form. Got a couple problems right now. One, I need x and y on the same side. It's okay, let's go ahead and get x and y on the same side, and we know that we're trying to get it equal to a number. So y is already alone. I'm going to get this 14 alone. I'm going to move this x to the left. Let me subtract 2/5 x from both sides. And because we know that it's got to go ax plus by, the a stuff needs to come first. That means the x term needs to come first. I got this negative 2/5 coming first. Sorry about that errant pen line there. Y was positive, and there we go. Can't have fractions, and I can't have that number in front of x be negative. I can handle both of those issues with one math operation without introducing more fractions. Ilya?
5/2.
Now, 5/2 will make sure that the number in front of x turns to a 1, but if I multiply by 5/2, I'm going to have 5/2y. And 70 over 2, which will reduce, but I don't want that 5 over 2. Why? Because I can't have fractions. So just the 5, but remember, it can't be negative in the front. So we multiply by negative and 5 at the same time. When we multiply, these two 5s will cancel each other. And when you multiply two negatives, you get a positive. So we just end up with 2x. Then I have negative 5 times y. And negative 5 times 14. And we've satisfied all the rules. It goes ax plus by equals c. My number in front of x is positive. And if I look at the numbers 2, 5, and 70, there's nothing I could divide all of them by except for 1. Ready to rock and roll. Good? Yes? No? Yes? No? Maybe so? What's up? Okay, he's making a face. And for those of you that would have reached for a calculator to multiply the 5 and the 14, don't do that. You all know what 5 times 10 is. 5 times 10 is 50. And you all know that 5 times 4 is 20. Well, 50 and 20 make 70. You don't need a calculator. Yes, Daniel?
About the negative 5, didn't you say that there couldn't be any negatives?
Not in the front.
Oh, so
A has to be positive.
Oh, so A has to be positive.
The B could be negative. B specifically has to be positive. For the next example, we're going to do the same basic stuff. Get x and y to the same side, and then go from there. Make sure we satisfy all the rules. I'm going to move that 10x to the left. Once again, I'm not going to be allowed to leave this front number negative. There's no fraction, so that's good news. But that front number can't be negative. But also, my three numbers, A, B, and C, cannot have a GCF greater than 1. And right now they do. What can I divide all three of those by? You guys can just say it. Well, they're all divisible by 2, but we're going to specifically go with negative 2 to ensure that the front thing is positive. So we'll divide all three objects by negative 2, reducing our equation to 5x minus y equals 8. Now it's standard form, and all the rules have been satisfied. Not bad, right? Pretty easy? Okay. I think I got a couple homework questions like that. I'm not sure. You know, I don't know if I put these things out of order or not, but I want to turn the page and do the one at the top of the page, and then we'll come back to this one. I might have just put it in this order for space reasons on the paper. I'm not sure. But this question I want to do before we do the 2-word problems. Cool? It says write the equation of a line that passes through 3, negative 5 and has a slope of 11 in point slope form. Here's point slope form. Y minus y1 equals m times x minus x1. Where the coordinate that we have, that is our x1, y1, and our slope is m. We're literally handed everything we need to do this question. We plug in x1, we plug in y1, we plug in m, and we call it a day because it says point slope form. So we say y minus negative 5 is slope 11 times x minus 3. There, done. That's it. Writing equations in point slope form is easy if you have a point and a slope. Right? Could I convert this to slope intercept form? Sure. I'd have to distribute the 11 and subtract the 5. But don't do that unless you needed to. This is point slope form. Call it a day. Okay, let's go back to the one before it. Now that we know how to write an equation in point slope form. In 2013, there were 1.31 billion smartphone users worldwide. By 2017, there were 2.38 billion smartphone users. Our job is to use that information to come up with an equation that models the situation, and then use that equation to estimate the number of smartphone users in the year 2025. All right, let's see. What color I want to write? Go to blue. I was given two x comma y pairs. Those would be the year and the number of cell phone users, well, smartphone users in the billions. So 2013 comma 1.31 billion. I don't want to write out all the zeros, so we're going to leave it as 1.31. And at the end, whatever answer we get, we'll know it's in billions, and we'll write billion. The other coordinate is 2017 comma 2.38. Oh. We need an equation. All I have is two xy pairs. What could I do with two xy pairs? If you remember back to Algebra 1.
1, 2 minus y1 over x2 minus x1.
Yes. What did you just tell me the formula for? Slope. Brock says y2 minus y1 over x2 minus x1. Yes, that is the slope formula. Just fill it out. Your second y minus your first y. Your second x minus your first x. I'm not even going to pretend to know what that fraction is as a decimal. .2675. That's our slope. The interpretation here is the number of smartphone users is growing by 0.2675 billion per year. That's a little more than 250,000, right? 0.25 billions would have been 250,000? No. 0.25 billion is 250 million, 250 million. There we go. I'm not sure if that's what I said originally or not. 250 million. The point is, it can't just be numbers. I need you to understand what it means. We're growing by 0.2675 billion per year. Great. Time to write our equation. And the reason why I want to do that one on the back first is because, hey, look, a point and a slope. Point slope form. It's our friend. So we're just going to fill it out. Y minus y1, which was 1.31, equals the m we found, 0.2675, x minus x1. And there is no reason to convert this to any other format. This is a fine format. It's got an x and a y in it, just like all the other formats do. Which means if we have a single number, either an x or a y, we can plug it in and solve for the other one. All we need to know is this year. Were yours x's or y's? You guys can just say it. Years were x's. That means I'm going to put 2025 right there. All right. This set of parentheses equals 12. And I'm not going to grab my calculator yet, because I'm going to get y by itself right now. The estimated number of cell phone users will be whatever 0.2675 times 12 plus 1.31 is. My calculator still has the 0.2675 on it, so I'm going to do times 12 plus 1.31 and hit enter. About 4.52 billion smartphone users. Point slope form is a very useful tool. Before we flip it over and do another word problem, you guys want to ask me anything about that? So if I gave you two coordinates, you could get me an equation of a line using slope and point slope. And worst case scenario, I ask you to put it in y equals mx plus b format. And all you would do is distribute and add and be done. A scientific calculator for the test? Yeah, if you need it, yeah. Yep. Yes, sir.
I'm just wondering, were you plugged in 2013 and 1.3? Because that also worked if you plugged in 2017 and 2.38.
Yes, so I know the formula says x1, y1, but that just means any coordinate that you know it goes through. So I could have used 2.38 and 2017 right there, and I've gotten the exact same answer down here. Absolutely. Alrighty, well then we'll go on to the next word problem, because everybody likes word problems. The Tower of Pisa began tilting during its construction in the year 1178 and continued to move until a restoration effort reduced the lean and stabilized the structure. The Tower of Pisa leaned 5.4 meters in 1993 compared to a lean of only 1.4 meters in the year 1350. Write an equation in point slope form that represents the lean, y, in meters, x years after its construction. So they've already told us the lean is y, the years are x. And after we have an equation, we're going to use that model to figure out what the year was when we were leaning 4 meters. Point slope form. And we were given two x comma y pairs. We know that x is the years. So I have 1993 comma 5.4. And I have 1350 comma 1.4. And just like I said a moment ago about which coordinate you used to go into point slope form, you know when you do your slope form in general, y2 minus y1 over x2 minus x1, you know it doesn't matter which coordinate you call x1, y1. I could say this is x1, y1. I could say this is x2, y2, no big deal. The order of the two coordinates doesn't matter. All that matters is that you don't mix and match. If you call this x1, this is y1. That's all that matters, is that you don't mix and match. Of course, I feel like it would be weird if you used the second coordinate as your first point, just because first, second is easier to look at. So I'm going to say the second y, 1.4, minus the first y, 5.4, the second x, minus the first x, well, the top is pretty simple. That's just negative 4. But the bottom, grab a scientific, so you don't have to use too much brain power. 1350 minus 1993 is negative 643. Ew, what an ugly denominator. This fraction doesn't reduce, and it's a terrible decimal. So what we're going to do is we're just going to leave it as a fraction. At least we could say it cleans up because both the top and bottom are negative. It'll be a positive fraction. That's the slope that we are going to use. We can write our equation now. And it doesn't matter which of the two coordinates we choose to be x1, y1, but since I used this one to be x1, y1 in my slope formula, I'm going to choose this one to be x1, y1 in my point slope formula. Go ahead and mark those so I don't goof that up. Y minus 5.4 equals our slope 4 over 643 times x minus 1993. There's no reason to do anything else with this equation. There it is, point slope form in all its glory. And if we know an x, we can plug it in and solve for y. If we know a y, we can plug it in and solve for x. I just need to know, based on what they told us, is the lean x or y? Lots of people can shout it out. It's a y. Look, it says right there, y meters. So that's a y value. So we're going to put it right there. I'm not going to distribute that fraction. That's horrible. I can subtract though. Negative 1.4. Oops, that's 4. Rather than distribute that 4 over 643, I'm going to get rid of 4 over 643. We do that by multiplying both sides by the conjugate. Reciprocal. Wrong word. Ilya, what's up? You sure?
Yeah.
Okay. We're going to multiply both sides by the reciprocal, which is 643 over 4. And this actually ends up being much prettier when it's done like this. Yes, Jake?
Wait, why do you add? Or like, I thought, why would the 4, like, how does the 4 go to the 5.4?
4 over the 5.4?
No, like, how'd you get rid of the 4?
I just subtracted 4 minus 5.4. It's negative 1.4.
So to get the 4 off the fraction, like,
I didn't get the 4 off the fraction. It's right there.
Trying to find x.
I'm trying to solve for x. What happened? Is everything okay?
Yeah.
Okay. If you multiply both sides by the reciprocal, those fractions will cancel over there. And this number is actually not that bad. 643 divided by 4 times negative 1.4. Not that bad. Negative 225.05. Now all we have to do is add 1993 to both sides. And what we'll do is we'll go ahead and round to the nearest whole year. So we'll say X is about the year 1768. I mean, it's like right there at the end of 1767, almost 1768. And on a test question, I would clearly be very clear. That's weird to say. I would obviously be very clear about how to round. It would say round to the nearest year. Or if it was a fill in the blank, it would say round to the nearest year. Okay? Would you like to ask me any questions about how that's done? Or can you all read through a word problem, pick out a couple pieces of data, and write equations? I think you can, especially since it's Algebra 1. This is literally a straight review. You've done this before. Your knowledge is probably a little dusty, but that's okay. In this same section, our textbook authors have decided to include sequences. And there's a reason why, which we'll get to in just a second. So what is a sequence? A sequence is a set of numbers in order or numbers that follow a pattern, which means they're probably still going to be in order, but they're going to follow a pattern. Every number in the sequence is called a term of the sequence. The first term is denoted by a sub 1. Often just say A1. The second term is a sub 2. The third term is a sub 3, so on and so forth. The word finite means comes to an end. So if you say you have a finite sequence, then you have a sequence with a known number of terms. I could say, oh, that sequence has 100 terms. That sequence has 57 terms, whatever. It's finite because I could get a number for it. I could tell you exactly how many terms it has. But not all sequences come to an end. Some sequences go on forever. We would call those infinite sequences. They have an infinite number of terms. For example, here's a sequence that you all know and love. 1, 2, 3, 4, 5, 6, 7, 8, 9, yada, 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 yada. That's the sequence of the whole number system. It goes on forever. It's an infinite sequence. The reason why this material is in this part of the notes is because some sequences can be defined by linear functions. But specifically, the inputs are whole positive numbers. If I give you a list of numbers, I could say the first number, the second number, the third number, the fourth number. You see how all of the number, let's say the place of the number is a whole value. First number, second number, third number. I never said what's the 3.5 number, because that's weird. You can't say that. It doesn't make any sense. I mean, when you go to the store and you start buying like loaves of bread, they don't let you buy 1 3/4 loaves of bread. If you open that package up and take some of it out, you will be kicked out of the store. Ask my grandfather. The point is, you have to buy these things in whole number increments. Okay? When you go to the pound and you start looking at dogs to adopt, you thank your lucky stars that you don't see 2/3 of a dog for adoption. Right? There's 1 dog, 2 dogs, 3 dogs, 4 dogs. Whole, no, okay, that's a little dark, Jake. I like to assume that all my dogs have all their legs, okay? Anyway, my point is whole numbers of things. And we can model them using linear equations. Specifically, the sequences that are arithmetic. When you're describing something, it's an adjective. So this word as an adjective is pronounced arithmetic. This word as a noun, meaning I'm going to do some math, is arithmetic. Thanks, English. But it's not an arithmetic sequence, it's an arithmetic sequence, okay? Arithmetic sequences are defined by addition or subtraction. So if you get from one term to the next, every single time by adding or subtracting the exact same value, you have an arithmetic sequence. Let me tell you an arithmetic sequence that you already know and love. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, you're adding 1 every time. 2, 4, 6, 8, 10, 12, 14, 16. You're adding 2 each time. These are arithmetic sequences. So if you were adding or subtracting a constant value, you're not multiplying, you're adding or subtracting. But a constant value to every term to get the next term, it's arithmetic. That constant value that you added or subtracted is called the common difference. You might be wondering why it's called the common difference. It's because we figure out what it is by subtracting. We take any term in the sequence and subtract the one before it to get the common difference. That's if we know it's arithmetic. So here we have a sequence that's written out, and it is arithmetic. And the reason why is because I can see from each term to the next, all that happened is one more common difference was added. The first term, A1. Then the first term plus the common difference. Or the first term plus 2 common differences. The first term times plus 3 common differences. So on and so forth. Where the common difference is found by taking any generic term, we say A sub n, where n could be any number it wants to be as long as it's greater than or equal to 1. First term, second term, third term, fourth term, so on and so forth. And we subtract the one before it. So if I wanted to know the common difference, I could take A sub 10 and subtract A sub 9. 10th term minus 9th term, that would give me common difference. Comfortable with that idea? And Any term in the arithmetic sequence can be found using this formula for the generic term or the general term. You are responsible for knowing this. The general term of an arithmetic sequence is found by taking the first term and then adding n minus 1 comma differences. So if I wanted to know the 10th term, let's just say I wanted to find a sub 10, I know n is 10, right? A sub 10 is a1 plus 9 differences. And this is included in these notes because think of d as being the slope. This is the number of slopes that I'm going to increase or decrease by being added to the first term. The main difference between arithmetic sequences and linear equations is arithmetic sequences can never have a y-intercept because n has to be greater than or equal to 1. A1 means the first term. You can't have the 0th term. That doesn't make any sense. And that's why we can't have n be greater than or equal to 0. Especially if I wanted to find a sub 0, which makes no sense at all, the 0th term. Oh, I would take the first term and do -1 comma differences. That's so weird. Okay, I found the 0th term. What does that even mean? I mean, the last time I counted something, I started with 1, and then I went to 2, and then 3. I didn't start at 0. Right? We start at 1 when we count things. So our sequences, because they're going to model real things, we're always going to start with the first object, and then go to the second object, and the third object, so on and so forth. And believe it or not, that's what we're going to call it today. A very simple, quick lesson. Everybody was super nerdy for me. I loved it. You can now do the first half of the homework, which is just the linear equation stuff. I'll talk to you again tomorrow.